Welcome students watching to today's lesson. So today we'll be talking about quadratic functions. So what do we mean by a quadratic function? The quadratic function is a polynomial of a second order. So if we have a function and we call it f of x is equal to ax squared plus bx plus c, we can see that the highest order here is 2, which is the highest power here is 2. So any function which has highest power to be 2 is a quadratic function. And there are some key things we have to find on the function, which is the minimum value, the minimum value, the maximum value, and then the vertex of the function. So if we want to know whether a function has a minimum value or a maximum value, we have to check with the coefficient of x squared, which is a. So if a is greater than 0, then it means the function has a minimum value. If a is greater than 0, then the function has a minimum value. Otherwise, if a is less than 0, then the function has a maximum value. So that being said, how do we find the minimum value and then the maximum value and then the vertex of a quadratic function? So we can find these three things analytically, and then we can also graph our quadratic function and then use points to find the vertex and then the minimum or maximum value. But today we will be looking at how to find the minimum value and then the maximum value using the method of completing the method of completing of squares. So what the method tells us is that we've been given our quadratic function, we should make sure the coefficient of x squared is unity. By unity, I mean the coefficient of x squared is 1. And the only way we can make the coefficient of x squared to be 1 is to divide the whole equation by a. So if we divide x squared over a, we are going to get x squared plus, we said we are dividing the whole equation by an a. So the coefficient of x2 becomes b over a, and then the constant becomes c over a. So now what we want to concentrate on is to expand the formula so that we can get oh, what we want to concentrate on is to expand the formula so that we can create and then destroy. So what we will concentrate on is the coefficient of x squared here, the coefficient of x, sorry, and the coefficient of x here is b. Oh, my pen is full. The coefficient of x squared here is b over a. So what we do to the b over a is that we multiply it with half and then we square it, so that we have what? B over 2a all squared. So now that we have this, we can write it, we can place it into our formula so that we have what? B over 2a all squared. Then we subtract the same constant from what we have. So we have minus b over 2a all squared plus c over a. So in natural terms, we can see that this term and then this term cancel out, but we do not want them to cancel out. So since we don't want them to cancel out, let's just leave it like this. So now that we have this term here, we can come and simplify our function and then write it as a into bracket x plus b over 2a all squared. So it's a into bracket x plus 2 x plus b over 2a all squared, because here the coefficient of x squared, we see that its highest power is 2, which is here. And then once we come to this constant b over 2a here, we see that its highest power is also 2. So we can group them into like terms, and then we'll have a into bracket x plus b over 2 all squared, then minus. So now here we can see that, oh sorry, so here we can see that we have minus b over 2a all squared, and that gives us minus b times b is b squared over 2a all squared becomes 4a squared. So we have this plus c over a, and that simplifies so that we will get this constant here. So from here we can see that this, once we equate x plus b over 2a to 0, we are going to get the value at which s occurs, or the vertex, and then this constant here becomes the minimum or the maximum value. So that is how we find the three major points, the two major points for a quadratic function. I hope we all understood what I explained. Please like, subscribe, and then share my videos. You can also leave a nice comment. If you didn't understand something too, you can leave it in the comment section and I'll deal with it. Thank you very much.